So what we're going to look at today, I'm going to go through not a real experiment with real samples, but just to kind of test one so we can speed it up because you don't need to see me pipette 12 lots of everything because you'll all fall asleep, I think. But what I'm following is the Oxford Nanopore's. So this is on their website. If you go on their community channel, this is kind of their very basic one. So it's kind of the test, the control one. So it says to use lambda DNA. So that's kind of their control DNA. But it's quite good because it's got all of the what to do with all of the bits of all the reagents. And to start with, so these are all of the reagents that we're going to use today. What we've got is the various barcodes. So there are 12 different barcodes. And so you can have 12 different samples running on one flow cell. Today, I'm just going to pretend to do 5. So we're only going to use the first 5. Then we've got the other reagents. So we've got loading beads, we've got sequencing buffer, the rapid adapter, and then flush tether, and flush buffer that we're going to use to prepare the flow cell, which we've already done. I showed you in another video, but we'll go through it anyway, just for this. So Nanopore suggests that you thaw, whoops, where did that come from? That you thaw all of the reagents at room temperature, and then you can put them on ice. So I have been thawing these at room temperature, so now I'm going to put them in my ice bucket so that everything is cold. Feel free to ask questions as I go through. And as I say, this is just a test run rather than a real run. Right, so all of my reagents are prepared and I'm ready to start doing stuff. The other things that you'll need are a waste bin, obviously, a timer, because there are various steps where you have to time incubations. You'll need nuclease-free water. You'll need your samples, and you'll need both PCR tubes and also low bind tubes. So we have these ones here, these DNA low bind tubes. So there we go. But I think there's a list of the stuff that you'll need on the document anyway. So you will also need a PCR machine or something that can heat your samples to 80 degrees and then 30 degrees. So you could use 2 heat blocks, but it's just easier to, for me anyway, it's just easier to use a PCR machine because we've got one. And obviously you'll need a min iron and a flow cell. So I think hopefully that's everything that I've remembered and prepared some pipette tips. So to begin with, we have to start and prepare our DNA. So you will need to have extracted your DNA. So these are my samples. So my extracted DNA, you need to be able to, thank you, Pico. So these are my extracted DNA samples. And what you'll need to do before you start sequencing is identify the concentration and also the size of the DNA. So with this protocol, what we're doing is the Rapid Barcoding kit, so RBK004. And this is sort of a quick protocol, but it requires a good amount of DNA and also good sized DNA and also clean DNA. So once you've extracted, it doesn't matter necessarily what extraction protocol you've used, as long as you can get the right size and quantity. So what Nanopore suggests you need is 7.5 microliters of DNA, and it needs to be about 400 nanograms. So that works out to be about 53.3 nanograms per microliter of DNA. That's what you need to be sort of aiming for. So you can test that using various different things. So the nanodrop, the qubit, or you can test it on something like the tape station or the bioanalyzer. The other thing that you also need to do is you have about 30 kb. So your DNA needs to be a certain size because Oxford Nanopore sequencing requires long read DNA. So with this version of the protocol anyway, with different kits, it might be different, but with this kit, it requires that you have about 30 KB or more as your average size. So you can either use gel electrophoresis to check the size, or the bioanalyzer, or a tape station. But those are two quite important requirements for this specific kit. And also to have clean DNA as well, because salts and things can block the pores on the flow cell. Right, so now we know what we need. Your samples, of course, won't necessarily be the exact amount. So what you'll need to do is work out how to get 400 nanograms. So you'll need to probably water some of them down, or dilute them with your water. So I will just go through and do that now. What I usually do is work this out. Usually the qubit is the most accurate representation of concentration, I find. So I tend to use the qubits suggestion. And then, as I say, dilute them down with the appropriate amount of water to get about 53 nanograms per microliter. So I'm going to pretend to do that now. Yes, but you need 7.5 microliters of your DNA. So whatever you've got with water and DNA, it needs to be a total of 7.5. I hope that makes sense. Excellent. So it doesn't really matter what pipette you use. I'm just, as I say, doing this for show. So just going to choose some numbers. In fact, I'm going to do that. So as I say, I'm going to pretend to sequence 5 different isolates. You can put different isolates together. So for instance, you can have E. coli and E. coli and Klebsiella and TB or whatever, because they will all be barcoded. So the computer will know which one is which, but you obviously have to barcode them before you put them together. And that's what this first step is going to be. So I'm just adding my water to my samples. Obviously, you're probably going to have different amounts of water, but the speed, I'm going to pretend that they're all roughly the same. Is everybody online keeping up with what I'm doing? Is it all right for everyone? I'm going to assume
yes, it's good. Everything is good. Yes.
Excellent. Thank you, Isabel. So now I'm going to add, so I've added my water. I'm now going to add some of my sample, each of my samples. And obviously, it's really important at this stage that you don't want to cross-contaminate anything, because you need to barcode them all. So that's sample 1. Sample 2. Sample 3. Sample 4. And sample 5. So now in each of our tubes, we've got approximately 400 nanograms of each of our samples. And hopefully they will all be at least 30 KB in terms of size. It doesn't matter so much if they're above it, but if you have a lot of samples, I found that it's best to try and make sure they're all roughly the same size as well, because otherwise you get some barcodes that will sequence more than others. So if you want to get a nice even coverage, it's best to try and make the samples as equal as possible. I've been experimenting with the idea of normalizing them in terms of femtomoles rather than nanograms per microliter and sizes. So yes, it's important to try and get them as kind of equal as possible so that you get even sequencing across all of the samples. Right, so we've made our samples. So now what we're going to do is add 2.5 microliters of what they call fragmentation mix, but on the tubes they're called RB01, and what that means is rapid barcode, I think, basically. It says fragmentation mix there on the side, but also, as I say, on the top they say RB 1, 2, 3, 4, 5, 6, 7. Obviously you don't want to mix, you need to make sure you know which sample you have added each barcode to. I tend to label my samples 1, 2, 3, 4, 5 as I go along so that I know that I'm adding barcode 1 to sample 1, because if you forget, then you're not going to know what you put in what. So yeah, so all I'm going to do now is put 2.5 microliters of my barcodes into each of my samples. So barcode 1 is going into sample 1. I forgot to add at the beginning, in the table at the top of this protocol, it says to spin down all of your tubes because they get frozen and they can get sort of dislodged at the top. So what I did before I put them on ice is I also spun them all down so that all of the samplers at the bottom. And you can also pipette to mix, or you can sort of gently flick. Some of them you can vortex, but others not. So as I say, it's just worth checking on the sheet what to do with what. So that's sample 1 with barcode 1, sample 2 and barcode 2. You can obviously label them however you wish, but this is my my idiot's guide. It's much easier to remember if they're all in the right order. So barcode 3 and sample 3. Barcode 4 and sample 4. And sample 5 and barcode 5. So now what you have in each of these tubes is a mix of your sample and also the barcodes. Now what we need to do now, this is when we're going to use the PCR machine or the heat block, is basically kind of stick the barcode to the DNA. And so as it says in the protocol, you incubate the tube at 30 degrees for 1 minute and then at 80 degrees for 1 minute. So as I said, I've already, because I do this quite a lot, I've already got a program on my PCR machine. So I'm going to incubate mine in the PCR machine. You can incubate yours, as I say, on a heat block. So that. Obviously making sure the sample is down at the bottom of the tube. So I will program this. Start. Okay, for your benefit, as you might be using this, the program is called MinION tagmentation, because what we're doing is tagging the barcode to the DNA. But I can show you how to use this properly.
Hi, Lindsay.
Hello.
I have just one question. I remember when we did the workshop, we used the magnetic field tracks. So why we don't use it here in this?
That's a different protocol. So you're right that in some of the protocols you do use magnetic beads to identify certain sizes of DNA. This is it's kind of a quick version of the protocol. So as long as you have a really the right amount and size and purity of DNA, you don't have to do any of those extra steps because you've already kind of confirmed that you have the right size and the right quantity of DNA. So this is just, it's the easiest kind of quickest protocol that you can do. It should take us, usually it would take maybe an hour or so. It might take me a bit longer because I'm explaining it. But yeah, so the beads are in other protocols. I mean, if for instance, you wanted to specify a really certain size of DNA, or you wanted to make sure that all of your DNA was exactly the same size, you could do a bead wash before. But as I say, because in theory you should have a good amount of DNA to start with, you don't really need to do it for this protocol. But yeah, that's the reason. Does that make sense?
Okay. Does it work also for arboviruses, this protocol, or no? Do we need to do the other protocol?
I guess it depends. If you have the correct amount of nucleic acid that you need, then yeah, I'm not really that familiar with sort of culturing of viruses. If you can get that amount of DNA or RNA.
DNA? How much DNA?
400 nanograms.
400 nanograms. Okay.
It's roughly 53 nanograms per microliter. But also, I presume with a virus, you'd need to get 30 kg as well, wouldn't you? So that would presumably be quite difficult for some viruses, I imagine. If you were I imagine this protocol probably isn't used that much for viruses because you need that amount of DNA. So you're probably more likely to use a PCR-based one or a ligation-based one. But if you go on the Nanopore community website, it will actually go through the different steps. You can put in the type of DNA or nucleic acid or organism and tell it what you want to do, and it will kind of provide you with a pipeline. So I recommend going on the Nanopore community website.
Okay.
It's really helpful.
Can you share with us that link on Nanopore? The links in Nanopore, yeah. Okay.
If you just type in Nanopore community on Google, it comes up. Yeah, you can just go through it that way. It's pretty easy.
Okay.
Great.
Thank
so
you
whilst we've been chatting, our PCR has probably finished. So I will take our samples out. Let's put that back. I'll forget about it. So for this protocol, that's the only time you'll need the heat block or the PCR machine. Now, so we've got all of our samples. They've now been properly tagged with our barcodes. So the barcodes are small sections of DNA that presumably have a certain sequence for each of the barcodes. And when they go through the pores, the computer will identify which one is which. And that's how it knows which one, which sample is attached to which barcode. So now what we need to do is we're going to pool all of our samples together in one tube and then gently mix it. So I shall do that now. So this, you can just pool them all together in one of the tubes that they're in. So I'm just going to pool them in number one. Again, it's up to you how you how you want to pool them. So you should have 10 microliters of sequencing mixture in each of the tubes. So you should have overall, well, I'll overall have about 50 microliters because each will have 10. If you have 12 samples, you will have 120. So because of those barcodes now, we can put them all together and it doesn't matter because the computer will be able to tell them apart. Yeah, exactly. So I'm just going to give them a gentle flick. Because you want long strands of DNA, the less aggressive you are with your mixing, the better now. So ideally don't pipette to mix because you're going to shear the DNA. So be as gentle and loving as you can with your DNA now. Well, throughout the whole thing actually, because as I say, you ideally want to have really long strands. So those are my samples all mixed together in a pool. This always makes me sad because you only need 10 microliters of all of those samples combined. So you're getting rid of quite a lot of DNA. So, but anyway, you only need 10 microliters of your pooled samples, which I have mixed. So I can get rid of that. And I'm putting this into a low bind tube. So that goes into there. So that's now 10 microliters of my combined samples into my pool. So in theory, because I have 5 samples, there should be about 2 microliters in theory of each sample in my pool, but that will vary depending on how many samples you have. Right, 7, thank you, yes. So now what we're going to do is add the rapid adapter. So this is a protein, I believe, that sticks to one of the ends of your DNA to help pull it through the pore. Hopefully Nanopore will correct me if I'm wrong, but I think that's what it does. So this, you just need 1 microliter. And again, you can mix your rapid adapter by flicking the tube and then spinning it down, which I did previously. So I want 1 microliter of my tube, my wrap, and I'm putting it into my 10 microliters of sample. This is often the thing that goes quickest. So I think you can buy rapid adapters separately. You should probably check that, but yeah, you'll find that the rapid adapter is the most precious thing. So look after it, because that's the thing that you'll use most of, I think, or quickest. So I'm going to give that a gentle flick to mix it all together. Now we're on to the second page. Now what we're going to do is incubate this at room temperature for 5 minutes. As I say, I believe that's what helps it attach the adapter to the DNA. So I can reset, I can't reset that. There we go. 1, 2, 3, 4, 5. So you just leave that for 5 minutes at room temperature. But I'm not going to sit here for 5 minutes because that would be quite boring. So after the 5 minutes at room temperature, you can then just put it on ice whilst you're preparing the rest of your kind of protocol. So do that. So now what we're going to do is, so this is something we covered in that other video, is we're preparing the priming buffer. So what we need to do, so this is the flow cell, and over, so this is where the pores are, and what it is a long kind of liquid filled tube, really, that's all it really is. And under here is where all the pores are. So this is the really important bit. And what it comes in when you buy them and when they get delivered is it's filled with a yellow storage buffer, and that enables it to maintain optimum pore safety, I guess. So that is stored in the fridge. But what we need to do before we start sequencing is flush out all of the storage buffer with a sequencing buffer. And so that's what we're going to make up now. So we've got flush buffer, which is the blue lidded one, and flush tether, which is the pink or purple lidded one. So what you need to do is put 30 microliters of the flush tether of the purple lid tube, mixing obviously and spinning down into the flush buffer tube. So each time you run a sequencing run, you'll use a whole tube of this. So you can just put a small amount of this flush tether into the flush buffer. Great. Now we can start preparing our flow cell. So this obviously will be attached to your computer, but for video purposes, we're going to do it over here. Flow cell is, as I say, this sort of water or liquid-based channel with the pores here, and then it's got this chip underneath. So this is the clever bit. This is the MinION itself is kind of, it heats it up and it stores or it transfers the data, but it's actually the flow cell that's kind of the important bit. So, right, so there's two different holes for the flow cell. We've got the spot-on hole, which is where you add the sample, but we've got this kind of hole which spins around. Ooh, I got my glove stuck. And hopefully you can just about see there's a little hole there. Yeah. So that is the priming port, and the priming port is specifically designed to fit the tip of a P1000. Now, I showed everybody in the other video and the other meeting that we had how to add the priming buffer without adding bubbles, but I will go through it again quickly, but you and I can practice in a bit. So to start with, you need to add 800 microliters of your mixed priming buffer. But to absolutely make sure you've got no air bubbles, and I can see there that that is air, not liquid. So what I'm going to do, always use the spinny thumb wheel, not the plunger, because you've got more control over that. So if you just stick the tip in of the pipette and pull it up until you see liquid. So now you know that there's liquid from the hole all the way through to the pores. So then you can add.
Okay, first we check if we have really liquid inside.
Yeah.
Okay.
So you need to pull it back to make sure that there's no air in it. And then you need to add this, which is the buffer. So I tend to make a blob to make sure again that there's no air, and then twist it, and you'll see hopefully that liquid will be pushed along. So if this was yellow, this is an old one, so it was clear, but if this was yellow, you'd see the yellow kind of being pushed along. And in fact, you can see it all there, look. So that's the old run that we did from earlier. But you can see that I'm just pushing liquid across. And you can see it all moving through. That's the waste port where the old buffer goes, and the old run, that's all the old run. So then I leave it with a little bit in just to make sure I'm not introducing any air. So that's the first section of the priming. Once we've done that, we can then start to prepare our sequencing kind of mix. So I'm going to get my pool of DNA back out. And now what we need to do is prepare the library. So we've got sequencing buffer, which is the red lid tube. We've got loading beads, and it's really important. So these have got little teeny tiny beads in. So it's really important that just before you take them out, you give them a good flick, because you want to get them evenly spread. So loading beads. Oops. We also need a small amount of water, and then obviously we're going to put it in with our DNA library. So let's just move that out of the way, put that over there. So we've got our pool of our DNA library. I need to add 34 microliters of the sequencing buffer. 34. So this is just a liquid. You just need to mix it and then spin it down. So 34 of that. 25.5 microliters of loading beads. So again, make sure you give these a good flick just before you put them in, because the beads will all settle to the bottom, and if you don't have a decent amount of beads, I believe the beads keep the sample down close to the pores, so it's not sort of floating around on top of the channel. So giving them a good flick. You can mix these with the pipette, because obviously this isn't our DNA, and add beads. Then we need to add 4.5 microliters of our water. And that is about 75 microliters of our prepared DNA library, which can then be added to the spot-on port. So that's ready to go. So we've done this, we've added the 800 microliters of the priming mix. Then we've made up our library. So now we can open the spot on hole. So that's where our sample will be dripped into. So there's a difference between the way you add the liquids. So with this one, you use the pipette to push it in. With that, you just sort of drip it on top, because as I say, the primary aim of this is to not give bubbles or not put bubbles onto the pores. So we've opened the spot on hole. So now both of our ports are open. So now we're going to add another 200 microliters of our priming buffer. But I'm going to do the same again because I'm really paranoid about bubbles. So sorry, I'm going to just make sure that we've got no air. So I'm going to suck up a little bit and then add 200 microliters again. So I make my bubble, and you'll find, so now that I've opened this hole, it's almost like a vacuum. It's liquid, but it's a vacuum. So you'll see if I put this on, it should start to suck it through. So generally it starts to suck, and you'll find when we put the sample on, it will suck it across. So I'm just going to add the rest of that, and you see it starts to come out of the hole, and it will suck it back in again. So I'm just going to add that. So that's the flow cell primed and ready to go. Now all we need to do is add our sample. So as I say, this is usually, I think it's about 75-ish microliters.
Yeah.
The complete amount of the library is about 75 microliters, I think. So again, just make sure that you kind of fix the tube to make sure that the beads are kind of fairly evenly distributed, and then suck up your sample. And then with this, as I say, you don't press the pipette tip into the hole. All you need to do is gently hold it over, and it will get sucked through by the reaction, not quite sure. Anyway, it gets sucked through, and you see that you can just gently drop it, and the sample will move across the flow cell panel like that. And then that's it, that's done. That is your sample loaded. So then all you need to do is just put the covers back, close them in iron, and then you can start on the computer. So yeah.